What's up guys, it's me Sir Ernest, and today we're going to solve problem 2-38 of Thornton and Marion 5th edition. The problem reads, the speed of a particle of mass m varies with distance x as this equation. So here is n is an integer. Assume that v at x equal to 0 is 0 at time equal to 0. So here we're going to find the force F as a function of x responsible to this problem, and we're going to determine the position as a function of time as well as the force as a function of time. Okay, so as you can recall, since a is your acceleration, which is the derivative of v with respect to time, and you know, by chain rule, this is equal to v times the derivative of v with respect to x. So therefore, the equation of motion F equals ma will now be equal to m times v times the derivative of v with respect to x. So this is now equal to m times alpha times x to the negative n times the derivative of this, which is negative n alpha x to the negative n minus 1. Okay, so therefore, the force as a function of x, we notice that this is a function of x, is now summarized or equal to negative m n alpha squared times x times negative 2n minus 1. So that is now the force as a function of x. Now on the other hand, letter b, we can determine the position as a function of time by solving this differential equation v, which is the derivative of x with respect to time. And we know that this is equal to alpha x to the negative n. So if we're going to integrate this with respect to time, we now have integral of x to the n. So we just transpose x to the negative n to the other side. So this becomes x to the n dx. This is equal to alpha integral of dt. So as mentioned here, at time equal to 0, the position is 0. At time equal to t, position is at x. So this will now be equal to x to the n plus 1 over n plus 1. This is equal to alpha t. Okay, and then solving this, we now have x as a function of time will now be equal to n plus 1 times alpha t to the 1 over n plus 1. This is now the position function of t, or position as a function of time. So therefore, letter C, the force as a function of time is you just have to substitute this expression or this equation here. So therefore, F as a function of time will now be equal to negative m n alpha squared times n plus 1 alpha t to the 1 over n plus 1 to the negative 2 times n plus 1. Okay, you can see what I did there. Okay, so simplifying this, we now have f as a function of time is now equal to negative m n alpha squared times n plus 1 times alpha t to the negative sorry, this should be, sorry about that. Okay, let's just have the parenthesis here should be outside. So this is negative 2n plus 1. Okay, so anyway, here this becomes 2n plus 1 over n plus 1. So this is now the force as a function of time. Okay, so that's it. That's problem 2.38 of Marion and Thornton, 5th edition. Thank you guys for watching, and I'll see you guys in the next video. Bye-bye.